we would not be providing you solutions, not because we are not capable of providing solutions, not because we are ill-read, but because simply of the fact that there are no solutions. Okay? There are no solutions. And if you are looking at any textbook on ethics, you will find that they deal with problems, they give you points of view, and they'll put a full stop and say, that's it. So there are no solutions as such. What we are doing now is providing you the theories which deals with these problems. So basically we are there to give you insights into the various theories that you implicitly use in your practice. You see, to make the matters more clear, Newton did not allow free falling bodies to fall to the center of the earth. The bodies were falling before Newton. What Newton did was only make explicit what was already implicit. So he was only making explicit a theory that was already there, with which we were fairly acquainted with implicitly, though not explicitly. So that is the job of these 6 sessions that you will be having on philosophy. Namely, we will be making explicit the theories that underlie ethical principles, and also how these ethical principles do not conform with each other. So what one theory says, other theories will say, no, that's wrong. Okay? So that's what we are basically planning to do here. Now, in other words, it's something like this. So you can say that there is practice. Underlying this practice is a theory. Whether you like it or not, every practice has an implicit theory that can be made explicit from the practice. So basically our focus is here, whereas usually as medical practitioners, as researchers, your focus is here. And the whole idea of having this conference is to make your focus shift from here to here. And that's basically what we will be attempting in the next 6 sessions. Now, to make this much more clearer, I take the example of geometry. Now, all of you use geometry, right? All of you must be staying in houses. You must have made tables, chairs. So you use the principles of geometry. Now, there is geometry in practice, but there is geometry in theory, which is called pure mathematics. So there are issues of pure mathematics which a person who is practicing need not be concerned about. So without being aware of these theories, you can still be okay with the practice. Now, if you enter into the theory, then you will see that there are a lot of problems pertaining to what you have been practicing. Okay? Now, what distinguishes you as medical practitioners, as researchers, from us, that is academic students of philosophy, is this, that we get stuck here, whereas you have to move from here to here. Right? You can't simply get stuck here, because if you get stuck here, you'll forget why you need them. Okay? So that's the reason that we are now shifting our focus to this. Take, for example, to give you a very good example, look at the definition of a line that you all have done in a class 10 standard, at least, that a line is a collection or a nexus of infinite number of points. Well, we have been using that, and we have been drawing lines all over. Even problematic is the definition of a point. A point is a dimensionless figure, and your teacher said, take a point P, and he drew a point. Now, theoretically, this is very problematic. Why? Because this cannot be a point. Because it has some dimensions. You see, you can measure it. It may have 0.1, but it will have something. So this is not a dimensionless figure. It can't be a point. And neither can this be a line, because a line has only one dimension, length. But no matter how fine your line is, it will always have 2 dimensions. But in practice, we don't use this explicitly. Okay, this is a line, fine. But when you enter into pure theory, underlying the practice that you do, you see that there are a lot of problems which have not been solved. Right? So there are theories which pertain to your practice on a day-to-day basis, right? Which you are not usually bothered with. Now, to give you a similar example, you might be aware that there are more than one geometry, right? There is the Riemannian geometry, geometry of curved surfaces, of which Riemannian geometry is one form. Then you have the Euclidean geometry. All they differ is simply on the definition of one thing, or rather, in a simple agreement whether parallel lines meet or they do not meet. Just change this, if I just draw 2 parallel lines and tell you, do they meet? And for all practical purposes, they don't. That's why you have railway tracks. Right? If they met somewhere, it would be a big problem. But now supposing I tell you theoretically, extended till infinity. Now in theory, that's a problem. Whether they can meet or they cannot meet. Now one way of saying is they meet and you have non-Euclidean geometry. The other way of saying is they don't meet and you have Euclidean geometry. But in practice, when you are laying down railway lines, you are not bothered with these theories, right? But these theories underlie your practice. So that's the point that I want to be clear and put across very clearly and explicitly as far as possible. Because you should not confuse the insights of the problems themselves as the solutions, right? What we are doing is only giving you insights into the theories that our ethical problems are dwelled or jacketed in. Now, however, this relation between practice and theory is not as simple as it appears, because it's not unidirectional. It is not from theories to practice. It's both ways. In other words, your theory, though it determines your practice, a change in your practice may also consequently change the theory. So it tends to flow both ways. That's why a person who practices something should also be aware of the implicit theories that govern their practice, because the flow is both ways. In other words, what I want to say is this. At the end of the session, you will not, if asked if this is ethical, right? If you are given a problem and asked if this is ethical, you may not be able to certify whether it's ethical or not, as you are doing now so very easily. Yes, it's ethical. No, it's not ethical. You may not be able to do this, but what you will gain at the end of the course is this, that you will at least be aware that this term ethical is a really messy term, because it can be used in so many ways and there are so many theories supporting all its various uses that it becomes problematic to come to this firm conclusion that yes, it's ethical, or no, it's not ethical, right? So that's the aim of our course. Now coming to the main point of the session, I would like to bring one thing into account without having further arguments at the present moment, that there is something which is called a distinction between I know and I believe. And this distinction is something which is usually merged. We have to be really careful about this distinction when not here. Here. This distinction is really important here. When I'm saying I know and I believe, there's a huge distinction. If you say I know that P, if I say I know that P, where P can be any expression. I know that this is a table. I know there are 30 people in this room. I know the color of this marks are red. So all these are claims of I know. Now if I make a claim which says I know, any other person who intends also to know P should be able to know P. In other words, any claim which says I know should have a set of justifications. That is what we call, how do you justify it? What is your justification for saying that? Right? So you should have a justification for every no claim. Belief, on the other hand, does not demand such a rigorous justification. I believe it. Now if you keep on saying, why do you believe it? No, I simply believe it. So there is this distinction between a belief and knowledge. So a claim which, when you say I know, must always be supported with something called justification. Now the catch over here is, this justification cannot be simply because I believe it again, because then you will be falling here. If you simply say, of course I have a justification. What's the justification? I believe it, and I strongly believe it. That's not a proper justification, because keeping the nature of the public nature of this claim I know, since it's accessible to all if they want to know, this justification should also be public in nature. So you cannot have private justifications. So I saw it in a dream will not be a justification if it is a case of no. I saw it in my dreams will be a case of belief, and you may even act on your belief. But there is this distinction which in theory you cannot merge. A distinction between belief on the one hand and knowledge on the other. Now, what happens if I say to hell with this? I simply want to focus on this. Then you go back, according to the Western philosophical movement, to the era of pre-enlightenment. That is, you become dogmatic. You do not use your reason. Okay? So, in other words, when you say, I know, this knowledge is never dogmatic. In other words, it always conforms to reason. So, any rational person should be able to see that your justification is in fact a justification of the claim P that you're claiming to know. And that's what separates the Enlightenment from the pre-Enlightenment period. Reason as the basis. Reason as the basis of all knowledge. What does it mean? It simply means this. If you make a claim, say a claim P, that P must be justified on certain grounds which must conform to the reason of each and every rational individual. So if you are a rational individual and I show you my justification for believing in P, you will automatically come to realize that P is true, that P cannot be doubted, that P cannot be challenged. Okay? Now, in cases of ethics, here itself the problem starts. Is ethics here or here? Because if ethics is here, that means if I say a position P is ethical, given the justifications I give for saying P is ethical, if P really is ethical and if it is a case of knowledge, then the justification should appeal to all rational individuals. Okay? Now, is it this or this? Traditionally, till the 20th century, it has been firmly believed that ethical principles are a case of knowledge, not cases of belief. Now, we will see in the later half of our course that in the 20th century onwards, there have been doubts with respect to whether ethics falls here or here. But for the time being, for the majority of your course, you will have to keep in mind that ethics is in this domain. Therefore, the problem of justification becomes very important. How do you justify something is ethical and something is not ethical? And that too, which will appeal to all rational human beings. So it should appeal and conform to the reason of each and every individual who is rational. Now, as in philosophy, as I've been telling you, there are a lot of problems. Now, here itself crops up another problem which I will just mention and sideline it. That is, who is rational? So, when we are saying that it should conform to the rationality of a rational individual, the immediate question is, who is rational? What are the criteria for determining whether an individual is rational or not? And there you land into a different debate in the field of theory, which we will sideline for the time being, and we assume that we all know what rationality means. Okay? So this is why justification is so very important in ethics. Why can't you simply get away by saying stealing is bad, it's unethical? Why does somebody always have to come up and say that, no, it may not be bad? Why does somebody always have to ask you, how do you know? Because when you're making a statement in ethics, you're making a statement of knowledge. And if you're making a statement of knowledge, you better justify it with proper modes of justification. Okay? And basically, we as human beings would like to always say that it's not merely my belief. It's something that is true. That is the question of objectivity. It's not my subjective belief that stealing is bad. It's an objective truth that stealing is bad. Now, for you to get this objectivity in your statement, you have to get objectivity in your justification. That's why justification becomes central to any ethical theory. How do you justify your ethical theory? Right? Now, this I'm not merely talking about individuals who are great names in the past. I'm talking primarily to all of us here. That when we say something is unethical, when you make that statement, you have to be clear whether you are making it as a statement of knowledge or whether you are making it as a statement of belief. If you're making, which in a large extent we do, make it a case of knowledge, I must have objective justifications to justify my claim. If you think that your reasoning is correct, please think again, because then ethics books will stop. all your books on ethics will stop. There will be one manual which will say what is ethical, and that's it. You know, you'll have like a textbook in mathematics. No two textbooks in mathematics differ except in the examples. Because nobody can say, if there are two textbooks in Euclidean geometry, nobody will say that in one parallel lines will meet, in another parallel lines will not meet. You can't have that. You see? Okay. So basically you need justifications. And the standard model of justifying is what philosophers or people, and please keep one thing in mind, by philosophers, please do not understand a person who is related with the department of philosophy. You all, when you are thinking in theory, become philosophers. That's why when you do your PhD, you get a doctor of philosophy. You may have done it in physics, but you will get it in philosophy, doctor of philosophy of physics. So any involvement with purely theoretical issues will involve you in philosophy. Usually in theory, any mode of justification is called an argument. Now please do not confuse arguments with disagreements. Usually we use the term argument to mean a disagreement, right? When I disagree with you, I argue, right? Or we are in an argument, we are involved in an argument. Argument here is a technical term used for justification. The mode of justifying something is an argument. Now, any piece of argument can be divided into two distinct aspects. Premises and conclusion. So you have premises and a conclusion. This is the format of any argument. No matter what argument it is, it will always have a set of premises and a conclusion. Now, usually terms like hence, so, therefore, therefore it follows, since are used to distinguish the premises from the conclusion in an argument. Or when you are justifying a belief, you use terms like hence, therefore, since, so on and so forth, to distinguish the premises of your argument from the conclusion of your argument. Okay? Now you really have to be good at this. When it appears here, when I'm speaking it out, it appears to be very easy. That, oh, I'll easily know which is the argument, which are the premises in the argument and what's the conclusion. Trust me, it's not that easy. Some arguments can be really complicated and you will not know what is the conclusion and what's the premise. So you'll have to be really good in differentiating what the premises are from the conclusion. Now this is important to you insofar as you are researchers. See, because when you're producing a research paper, right, you have argued out. So you must be clear in your head at least what are your premises and what is the conclusion that you are drawing. 1, 2, whether your conclusion follows from your premises, right, and 3, how would I know whether it actually follows or not. So that's basically what we are going to look, the nature of justifications or the nature of an argument. Let's take it this way. The light, the time taken by a light traveling from a star to reach your eyes is some, say, x light years. That's the time taken by the star. Okay? Therefore, the things that you're seeing right now is in fact the star as it was that many light years before. Right? Now here, using the word therefore, you can easily distinguish that the premise is, number 1, that light, the distance that is there between the star and the planet or your eyesight. 2, the time that is taken to travel, right? And 3, given this truth of this premises, we can now conclude that therefore the things that we are seeing in the universe is in fact not now. So the star that you see blinking in the night may not be there at all at the present moment. It may be there some 20 years back. It may no longer exist, so on and so forth. So in these ways, for example, a standard example is all men are mortal. I am a man, therefore I am mortal. So given the truth of the premises, all men are mortal, I am a man, therefore I am mortal, becomes an argument where you can easily distinguish the premises and the conclusion, right? The problematic situation now that faces you is how many arguments can you have? If I raise this question, how many arguments can you have? So what would be the possible answer? Lots and lots and lots. right? We can just simply sit down and keep on making arguments after arguments and arguments after arguments, given that an argument consists of premises and a conclusion. So therefore, how do we study arguments? Because if it's not possible for me to study each and every individual argument, because there is no such totality available to me, right? Because I may take up 1001 arguments and sit down. And the minute I sit down, somebody comes to me and says, wait, I have one more argument. Here's 1002. And so I'm examining it in between. Somebody comes, here, 1003. So this, you can always add n plus 1, as it's said in mathematical terminology, you can always have n plus 1, right? So it becomes very difficult. In fact, it is an impossible task for you to consider every single argument. So what did logicians do? They used mathematics once again. Now in mathematics, if I ask you, how many sums of addition can you have? Again, you can say n number of sums, because you can just take two numbers, and since there are no finite set of numbers, you can always have n plus 1. So you can have infinite number of sums of addition. But what all these sums share in common is the form, or what is generally called as a formula in mathematics, right? So for a sum, we say x plus y is equal to z. Of course, we are talking about natural numbers and whole integers, right? So x plus y is equal to z. Now, no matter what sum you come up with, it will essentially follow this form, right? So though you may have infinite number of examples, all examples that you can collect together will conform to this form, because this is the form of an addition. Now, if it is possible for you to come up with the form of an argument, then you need not study each individual case. You can simply study the form, right? So there was this quest of finding out the form of the argument, and fortunately, something that philosophers have agreed upon is the fact that there are two forms of argument. So these two forms are inductive and deductive. So an inductive argument form and a deductive argument form. So when we are saying that there are two forms of arguments, we are saying that they are irreducible. You cannot reduce one form to the other form. Is this clear? I know I am getting a bit technical, but I intended to be, because since you all are now this is the advanced program, so I thought that you should have something concrete. Now what are the two forms? One is when you have a general statement. A general statement is a statement which has the proposition all or no. So no men are women is a general statement that is true, right? All men are men is a statement again which has all, is a general statement, which means it pertains to the whole class of whatever you are talking about. So if you are talking about all men are men, you are talking about the class of men, and every individual is involved in this class. Nothing is excluded. In other words, your scientific laws are usually of this nature. All free falling bodies will fall to the center of the earth, no exceptions included. Of course, they have exceptions, and scientists are good enough to cover it up by saying these are exceptional cases, right? Or all solids expand on heating. Some don't. So they quickly say exceptional cases, right? But they basically mean all. So this is a kind of a general statement. When you have a general statement, okay, and a premise followed by a conclusion. Now please, I would just like you to focus a bit technical. If your conclusion is about something, if your conclusion is about something which is already included in this all, okay, that makes it absolutely true. In other words, let me replace this. All men are mortal. I am a man, therefore I am mortal. Now if you look at this example, all men are mortal, I am a man. The truth of the premises already includes the truth of the conclusion. Why? Because whatever you are concluding about is an element of the general class. So truths in this sense cannot be doubted. You cannot doubt them. Given that the premises are true, you cannot doubt the truth of the conclusion. Now you may think, where can they use? Because see, first of all, it is non-informative. You are not gaining any new information in the conclusion, because the information is already there in the premise, right? In other words, you are only making explicit what was implicit here. What was sort of, yes, so which are something which are hidden, you are making it more explicit in the conclusion. Now you might simply ask, where do we use such kind of arguments? Now whole of your mathematics is based on this. Given the truth of the definitions, okay, you cannot doubt the conclusion, because the definition already contains the conclusion. All of your Euclidean theories can simply be derived if you take Euclid's definitions to be true. If you take those definitions to be true, these are your premises. Okay? Since the definitions are true by premises, I get this as my conclusion, because the conclusion is already contained in the premise. That's how you derive theorems. When you are deriving a theorem, you do not use anything else apart from what is already given to you by Euclid as true in his definitions and propositions and axioms. Right? Is this clear? So this is basically what we do in a deductive mode of argument. So in a deductive mode of argument, we have a general principle followed by a principle and then the conclusion. A premise, a general premise and a conclusion. Now please keep one thing in mind, sometimes deductive arguments can be tricky because they apparently do not have this general premise here. Okay? But we'll leave that aside for the time being, and for simplicity's sake, we'll take this as a standard model of a deductive argument. Now if this deductive argument is the only argument possible, then it becomes a big problem for human beings. Why? Because now you cannot have access to new knowledge. Because the conclusions that are proved in a deductive argument is already known. So how can knowledge progress further? So there must be, since knowledge is progressing further, I'm again using an argument, right? So you can now find out the premise and the conclusion. Since, okay, knowledge is progressing and deductive arguments do not help us acquire new knowledge, therefore there must be something else apart from deductive argument which is helping us progress further, right? So what is this argument? Then this argument form is the inductive form. Now in science, usually you use this form. A is a crow, it is black. B is a crow, it is black. C is a crow, it is black, and so on and so forth. Therefore all crows are black. Now this is the usual kind of reasoning that most of you are acquainted with. I give this medicine, this happened. I give this medicine again, this happened. I give this medicine again, this, therefore if I give this medicine, this happens. So it's a sort of an inductive argument that we are most of the time involved with, but we are involved with it implicitly. We do not know that we are using this argument form, and the worst part is that we do not know what are the follies that are hidden behind using this argument form. Okay? Now here you know that given the premises are true, the conclusion is absolutely true. There you can't doubt it. Here, given the premises are true, can you doubt the conclusion? See, the problem is this, it's not simply sometimes. You can never be certain about this. For the simple reason, theoretically, when I'm speaking about all, I'm speaking about a class, right? Now I may say in n numbers of this, maybe millions of a crow being black, but that million will not constitute the whole. Why? Because you have not yet seen future instances. So future instances you have to leave, even if you want to leave a very small part, you still have to leave them. So it can never be about all. So though you say all, you still have a little bit of doubt that, well, it may not be, which we generally ignore. Which when we use this argument, we ignore this part of our argument. We tend to argue that no, it's absolutely certain, which in theoretical terms you can't be. because you have already left, no matter what, in using this argument, this small portion. You may be more generous and say this portion, but you have to leave a portion out. And that portion ensures that you cannot basically, okay, be really sure about the all statement here. Now, to give you historically and to be more authentic, this principle was challenged by the philosopher called David Hume. David Hume wrote a treatise called Inquiry, and there he raised this question which philosophers have been trying to solve over the periods, but none have come with a conclusive conclusion which will end the matter there. And the question that Hume raised was, will the sun rise tomorrow? Will the sun rise tomorrow? Now, till now, I'm sure if you ignore this theory part, you'll say, of course, what a dumb question. It will rise tomorrow. And why? Because given the laws of nature, this is this, and so it will rise. Really? Now, if you think in terms of theory, you have a big problem here, because you can't be sure that the sun will rise tomorrow. And then there have been a lot of efforts, of course, which we are ignoring, okay, to show that the sun will rise tomorrow, and Hume was wrong in doubting it. And the immediate response to Hume was in the works of Immanuel Kant, Critic of Pure Reason, okay, where Kant argued against Hume and showed that the sun will rise tomorrow. Now, we are not getting into that because that will be a totally different field altogether, but just to give you the sense that you have these argument forms, and though over here you have absolute certainty, you don't have novelty. Here you have novelty, but you don't have absolute certainty. And now for the real catch, science uses both of these, because from where does it get its general principle? Where will it get its general principle from? They don't believe that God will whisper it in their ears. So where do they get it from? They'll have to get it using an inductive argument. Now, if their inductive argument comes up with a premise which is doubtful in itself, the deductive argument itself will be doubtful. In other words, what we are calling here an inductive argument is what gives rise to theories in science, right? You make observations and you come up with a theory. Okay? Now, for example, to give you how this works, say for example, you have studied planet movements of heavenly bodies. Okay? So, just to get the feel of it, take this example that scientists have been studying planetary motions. They don't know what is a planet yet. Okay? They are just studying heavenly bodies. And they come to realize that there is this group of heavenly bodies which acts in this way all the time. By all here, they mean all the instances when they have been observing, right? So, X is a heavenly body, given X, it becomes Y. Y is a heavenly body, given this, it becomes, so all of them. So, therefore, all heavenly bodies of this nature behave in this way. Okay? So, now you have an all statement, but you still know now that it is subject to doubt, right? It's not absolutely certain because you have this small speck here which is pinching you all the time. Right? So, this is not absolutely certain. Now, what happens? You see a new heavenly body X somewhere there behind the last planet. Okay? Now, we don't even know which is the last planet because every 5 years, 6 years, they come up with a new planet. Right? So, now the last planet I think was planet X. So, they have not yet named it. They have said planet X. Now, planet X, supposing, how do you know it's a planet? Because you say all planets behave in this way. X is a heavenly body which behaves like this, therefore X is a planet. So, in other words, what happens is your small bit of doubt which you leave open here gets carried forward here. But this is not bad. Don't look at it from a negative perspective. The positive perspective of this is that is why science is open to progress. Somebody can always say, no, we were wrong. Why? Because now when I study this small speck, this whole thing collapses. Though it is said that in an inductive argument, one negative instance can nullify your whole argument. For example, before Australia was discovered, people thought that there were only white swans, because all swans till now were white. They saw that there were black swans. One instance of black swan has the force to negate all of your millions of observations. Okay? But of course, to say this would be to say that science is very rational in this sense of the term. It's not that, because science will now try to protect it by saying that no, this is not a swan, you know, or no, this would have been a white swan, but you see this X, Y, Z were not fulfilled. If X, Y, Z, it would have been white, right? That's how we go. This is what the famous philosopher of science Kuhn said as ad hoc hypothesis. You keep on adding ad hoc hypothesis, ad hoc hypothesis, ad hoc hypothesis, you know, and at last you come to a point where your ad hoc hypothesis is greater than your hypothesis itself. So then you will have to give up this and develop a new hypothesis, which is how science progresses. You know, these are all philosophy of science things that take place. So this is basically what I wanted to say about the form. Now, since all of us are hungry, I intend to stop here and we'll continue this session in our next meet.